a co-production of Latitude Media and Canary Media.
Since we're talking about tough stuff, what's the toughest thing you've ever had to build in your life?
I was going to say the tree house that I built with my dad when I was a kid, but I don't think I did that much work.
A few years ago, my husband and I remodeled a family house in Ohio and built an IKEA kitchen. And there's like thousands of parts involved in doing that. And so a few shattered glass doors in the process, but it came together.
Wait, a whole IKEA kitchen? I'm on an IKEA standing desk, which took me like 4 hours to put together. I can't imagine a whole kitchen.
Yes, it's a journey.
Sounds like stuff of nightmares. But yeah, I was thinking back to, I think it was middle school. My friend Alex and I decided to just build a little trebuchet for fun, which is like a kind of medieval siege engine akin to a catapult, but like it kind of swings through, if you can picture that. And we took it down to the park and like flung tennis balls.
Did it work?
It got the balls through the air. I don't think it was like necessarily farther than you could do it with a lacrosse stick or something, but it propelled items.
This is the Carbon Copy, and this week we're tackling the tough stuff. The industrial sector is set to overtake power generation and transportation as the biggest source of planet-warming emissions in the U.S. by 2035. The sector's impact is even greater on the global scale. Industry around the world accounts for more carbon dioxide emissions than all forms of transportation combined. And that's largely driven by steel, cement, and chemicals. There are a lot of ways to decarbonize industry, but the pathways are much less clear than for electricity or automobiles. And in this episode, we're exploring the varied paths for cleaning up the products that are foundational to the world around us.
America's green banks are preparing to unleash a wave of capital for clean energy. The Greenhouse Gas Reduction Fund invests a historic $27 billion in projects nationwide. This could mobilize up to $150 billion of private capital for solar, storage, efficiency, and electrification in underserved communities. So how do we deploy those billions quickly, efficiently, and with the highest impact? On July 18th, Latitude Media and Banyan Infrastructure will host a virtual event exploring the on-the-ground realities of making America's green banks a success. Register for free by clicking the link in the show notes or go to latitudemedia.com/events.
I'm Stephen Lacey, executive editor at Latitude Media, and I'm here with my friends and colleagues from Canary Media, Maria Galluci, Jeff St. John, Julian Spector. Maria is a clean energy reporter who focuses largely on the hard-to-decarbonize sectors. This is your week to shine, the tough stuff week, Maria.
Yes, my call to fame.
Jeff St. John is the director of news and special projects at Canary Media. Hey, Jeff.
Hey, Stephen. Thanks for having us.
And Julian Spector is a senior reporter at Canary, covering a wide range of topics, including storage, manufacturing, and industry. And you are in Portugal, which surprised us when you signed on. I am a little bit jealous of your travels.
It's been fun. It's been fun. But, the reporting keeps me rooted in the world of American industry and energy transition. And I've been covering the hydrogen side of this industrial decarbonization topic because a lot of movement on that front.
So yeah, let's set a little context here, and then we'll dig into some different areas. Getting to net zero emissions in the power sector or in transportation is an extremely heavy lift, but it's become increasingly clear how we get there. And most of the emission reductions here in America that we'll see, thanks to the Inflation Reduction Act, are going to occur in those areas, according to the Rhodium Group. And industry is a very different story. As I mentioned at the top of the show, Rhodium projects that the industrial sector is going to be America's highest emitter by 2035. And that's because steel, cement, chemicals, the dominant industry polluters, require extremely high heat, require massive capital investments, and rely on equipment that lasts a very long time. And of course, we need heavy industry to support the build-out of batteries, renewable energy power plants, efficient buildings that are going to get constructed in the coming decades. So its role is more important than ever, but the pathway to decarbonize it is still unproven. So Maria, Jeff, and Julian have spent a lot of time digging into the different solution sets for industry, and we're going to riff on many of them today. So I want to start with just talking about the different sectors that you focused on. We're looking at cement, concrete, chemicals, steel, and hydrogen. So Maria, you took on a bunch of different sectors. Why don't you start? You focus on cement and concrete, ethylene, and steel. Where's the best place to start? What's the hardest one?
Oh, the hardest one, I would say chemicals, probably because it's not just, all of these industries are difficult, but chemical manufacturing means many things and there's many different pieces. And to be honest, we just kind of scratched the surface of that with this themed week. We spent more reporting on steel and cement and concrete, in part, I think, because there is a lot more activity and movement around efforts to decarbonize, whereas the chemical industry seems like just starting to wrap its head around this possibility of decarbonizing.
Yeah, so why did you focus on ethylene?
Yeah, ethylene is a key building block of a lot of the other chemicals that are made in everyday materials like diapers, detergent, most of the plastic materials that we have, PVC pipes, even airplane wings have some ethylene. So that seemed like a great place to start because ethylene is in a lot of stuff. Ethylene is in a lot of the materials that we use. It's also the most consumed primary petrochemical. Kind of among these groups of what are called high-value chemicals, it's the most consumed. So that seemed like a good place to start. And also because in my reporting, I noticed there were some interesting initiatives to try and electrify parts of ethylene production. And so that seemed like a cool opportunity to focus on an area where there actually are solutions, or I should say there are steps toward solutions within the chemical space.
And so in the chemical space, for ethylene in particular, we're not necessarily talking about a change in chemistry. We're mostly talking about electrification. Is that right?
Right. So in my story, I focused on sort of the most emissions-intensive part of ethylene production kind of within the walls of the plant itself, and that is generating high heat to crack ethane gas into ethylene molecules, which are then processed into other chemicals. And so this process of generating heat to crack ethane accounts for 90% of the carbon dioxide emissions associated with an ethylene steam cracking facility. So I focused on initiatives to electrify that portion. But you're completely right that a huge part of sort of the life cycle emissions of ethylene and all chemicals come from the fact that they are oil and gas feedstocks. And even electrification can't fully address some of these other issues that come with ethylene and plastics more generally, and that is they generate a lot of toxic air pollution. They generate a lot of plastic waste that ends up in waterways, in our bloodstreams, et cetera.
Yeah, I thought the approach to this sector was interesting because it's very small in terms of actual heat-trapping gases compared to some of these other industrial sectors, but it's an industry, it's a sector that's only just now toying with decarbonization and electrification. And you quote one expert who said, if you had mentioned electrification in the chemical industry a few years ago, no one would have taken it seriously, but that's changed pretty dramatically. So starting to see some shifts there. So let's turn to steel now. Maria, you were on the show a couple weeks ago, and we talked in depth about the different methods for producing green steel and the efforts to procure more green steel to actually create demand. So you and Jeff took a look at the different elements of clean steel production. Maria, why don't you just give us a quick overview, and then Jeff, I want to turn to you about some of the production methods that you looked at.
Sure. So the steel industry is responsible for as much as 9% of CO2 emissions worldwide every year. And the majority of those emissions come from the blast furnaces and the basic oxygen furnaces, which heat and process coal products, fossil fuels, to essentially turn raw iron ore into iron that becomes steel, that becomes high-strength material in buildings and cars and bridges and roads and many, many things. So that's sort of when you think about cleaning up steel or decarbonizing steel, really the big question is, what do you do to get away from the blast furnaces and basic oxygen furnaces?
I looked at a particular approach to creating not green steel per se, but green iron, the precursor to feeding into an electric arc furnace. And this particular process is called electrowinning. And it's essentially putting metal ores into kind of a solution and then zapping it with electricity in a way that separates out the pure metal, molecules from everything else that's in the ore. Electrowinning is used today to process copper, nickel, and zinc. Iron has been a much tougher climb. There are a lot of complex scientific reasons why iron is harder to electrowin out of solution than other metals. But this company called Electra out of Boulder, Colorado, is working on a process that it's piloted, showing that it can get pretty pure iron, like 99% pure, out of this electrolysis process. And there are some other companies working on it as well, and a big consortium in Europe. And the idea there is that you could not only get pure iron to feed into these electric arc furnaces to make steel, but you could maybe process even lower quality iron ores than are kind of practical to process today using basic oxygen furnaces, or the direct reduction of iron process using hydrogen, which is kind of the big way that people are talking about doing green steel today.
I know that Electra raised a bunch of money from Breakthrough Energy Ventures and Amazon and some other investors. What are they promising right now, and how close to commercialization are they?
Well, they're working on a pilot plant. They say the technology works, and there are some other folks, actually Fortescue, the big iron mining and hydrogen giant out of Australia, has mentioned that it has a process which sounds something similar to electrowinning for making pure iron. I guess the question about commercialization is, how do you scale that up, and how does the kind of iron and steel industry see its value? It's interesting that you can kind of build these things on a modular basis, kind of like batteries. You line up a whole bunch of these things and you produce iron out of them. And that can be done at much lower temperatures. And you can kind of, go as big as you want to go, which is different than building a big old, direct reduction of iron kind of plant. And then if you can find a business case for using those lower quality iron ores, that could be a real selling point. But it's going to take a significant commitment of capital from somebody who's in the iron and steel business to answer that question.
And Jeff, a very important part of this, did they come up with the term electrowinning? That just seems like a great brand, great kind of thing to put out into the market. Very positive. But where did that name come from?
They did not come up with electrowinning. That's the term of art that has evolved from this kind of ongoing kind of area of research and technology that's been around for hundreds of years, actually. But the resulting metals are said to be electro-1. So I guess if you want to be winning, it's a great technology to bank on.
I think we all want to be electro-winning.
Definitely. And then in theory, they can take this iron that they're creating through the electrowinning process and feed it into electric arc furnaces. And then those electric arc furnaces can be run with renewables, right? Like that's the idea.
Indeed. That is also the idea behind, direct reduction of iron using hydrogen as well. The big shift is from those big, blast furnaces, which burn a lot of coal, to the electric arc furnaces, which run on electricity.
And that mention of hydrogen brings us to Julian, who took a look at the green hydrogen market, or the lack thereof. Significant promises, significant plans to develop green hydrogen projects, but not a lot of demand out in the market right now. So what did you find in terms of where the hydrogen market stands and where it could potentially benefit some of these industrial applications in the near term?
Yeah, so I was able to let my colleagues do the hard work of figuring out why specifically these industrial pathways require a clean source of hydrogen. My job was just to find out, do we have enough? Where is it coming from? Do we have any, really? And I did come around to thinking there is something happening here. I think as a skeptical reporter, a lot of the hype cycle around green hydrogen seemed pretty dubious in the last few years, just because there's so much talk and no one was actually going out and building facilities to produce green hydrogen. It seemed like a way for, say, a fossil gas utility to keep investing in gas infrastructure, because it could say, hey, one day it'll be all hydrogen, don't worry. And what I found is today there actually are a lot of companies going out and developing hydrogen production to make money on it, just the way that there are a lot of people developing, wind and solar projects or battery projects. And it does seem to be kind of the newest up and coming form of clean energy development business afoot. And then that actually got a major boost just a few days ago when President Biden announced these hydrogen hubs, where the DOE is putting a total of $7 billion into these regional clusters of hydrogen production and use and transportation and distribution in different corners of America. Now we should say there's dirty hydrogen and then a whole spectrum to very clean hydrogen. So the term green hydrogen gets thrown around and it can be a little fuzzy, but at best we're talking about taking clean electricity, carbon-free electricity, running that electricity through water, through the electrolysis process, and that produces hydrogen that has very low carbon impact. We actually don't have capacity to do that in the U.S. today. There's a lot of fossil-based carbon-emitting hydrogen in the U.S. today. I couldn't find any commercial scale, real operation pumping out green hydrogen yet. But I found a lot of companies that are either constructing right now or about to break ground, and then a whole bunch more are moving ahead now they know about the Department of Energy funding for those hubs.
Yeah, and we also took a look at the electrolyzer market at Latitude Media recently, and what we found is something similar to what you wrote about, which is kind of a chicken and egg problem. Some of the, there's a concern from project developers that there's not going to be enough demand, and there's not a lot of demand because there's not a lot of production, and so we're stuck in this kind of holding pattern. Did you find, are you hearing the same thing?
I think we're going to break out of that pretty soon. Today, it's been hard for the people who make the electrolyzers to produce a ton of electrolyzers because if there's no one actually using electrolyzers in the U.S., who do you sell to? Although there is some, happening in Europe and elsewhere in the world. But basically, there's now so many developers who are buying up whatever electrolyzers they can get their hands on that I think that's starting to give much more of a signal to the manufacturers to ramp up their production. And then on the other side of it, you need the industrial customers to say, hey, I want to buy the hydrogen, the carbon-free or very low-carbon hydrogen. So that's another chicken and egg problem because, like we talked about, there's people talking about substituting hydrogen to reduce the iron ore to make the green steel, but no one's doing that in a kind of big commercial way yet. So you can't really sell your green hydrogen to green steel makers until they're ready to use it. And so one kind of interim route I found is there is a market today for vehicles, for hydrogen fuel cell vehicles that need liquid hydrogen. And it turns out the price point for liquid hydrogen today is significantly higher than the kind of gaseous and industrial hydrogen that's produced by fossil fuels in Houston and the Gulf Coast and stuff. So a few of the companies like Air Liquide and Plug Power are constructing their green hydrogen today to sell it as a liquid for the fuels market, where they think they could be much more competitive against the higher priced market that exists for that right now.
On July 18th, join Latitude Media and Banyan Infrastructure as we take a deep dive into the next phase of deploying the $27 billion Greenhouse Gas Reduction Fund. We'll provide practical insights for the state agencies and local lenders at the front lines of dispensing these funds. Where are the bottlenecks? How do we balance speed with transparency? And can America's green banks live up to the expectations of both local communities and Wall Street? Latitude Media's Stephen Lacey, Banyan co-founder Amanda Lee, and Clean Energy Fund of Texas EVP Billy Briscoe will answer these questions and more on July 18th at 1 p.m. Eastern. This is a must-attend for project developers and financiers. Register for free at latitudemedia.com/events or click the link in the show notes.
So let's turn to the last sector that y'all are covering, and then I want to dig deeper into each of these, cement and concrete. So I had a good friend who ran a concrete business, and he poured foundations and sidewalks and stuff. And if you ever called what he was pouring cement, he would get very upset because the final product is concrete. But cement is a very important part of the full concrete mix, and it is the most emissions intensive piece of concrete. And so I know that Jeff and Maria, you both looked at different parts of the cement and concrete business. So Maria, why don't you kind of start and tell us a little bit about why cement itself is so emissions intensive?
Sure. Yeah, and you're totally right about the wording. This is a tricky industry to cover because there are so many different phrases. And as somebody, who's kind of outside the cement/concrete industry, learning a lot and trying not to put my foot in my mouth. But so in general, the cement and concrete are responsible for about 8% of human-caused CO2 emissions every year. About 40% of those emissions come from burning fossil fuels to heat the kilns. The other 60% comes from the chemical process of calcination. So that's when limestone in the cement is heated, it breaks down, it releases its calcium oxide and its CO2, and the CO2 goes into the atmosphere. So that's what's so tricky about cement is that CO2 is literally baked into it and then, released into the atmosphere. So the challenge then is to find ways to either reduce the use of cement or make cement with different materials so that you're not having that challenge.
Maria summed it up well. Calcium carbonate, i.e. limestone, CaCO3, is roughly speaking half carbon dioxide by weight. And so the way you reduce the carbon impact of cement is in some ways to reduce the reliance on the core material and process of cement making that's been the main way we've all made cement for hundreds of years. Well, about 150 years to be precise. But there's some real high hopes of getting at least, roughly speaking, a third to a half of that emissions down significantly in relatively short order, and with not just relatively low cost, but perhaps some kind of value premiums to the industry. I was talking to Vanessa Chan at DOE's Office of Technology Transitions, and DOE put out this liftoff report on cement that pointed out that there are some really, kind of short-term methods to essentially reduce the amount of Portland cement, that's the kind of core material, the limestone-derived material that Maria described, with alternative materials, essentially. They're called supplementary cementitious materials sometimes, or clinker substitutes, because clinker is the stuff, the CaCO, that comes out of the kilns, with other stuff. You can do it right now by just adding ground up limestone in 10 to 15% proportions to the amount of cement you're putting out there to the market. You can add fly ash, the stuff that comes out of coal plants. You can add steel slag, the stuff that comes out of, steel blast furnaces. You can add different types of clays that you pull out of the ground. And by reducing the proportion of Portland cement that goes into your cement mix, you're reducing the carbon emissions that is tied to the amount of that cement you put in. And so these supplementary cementitious material kind of processes don't just kind of cut the amount of embodied carbon, depending on the type of technology you're using, by 10 to 20 to 30, maybe sometimes even 40%. They can also give you a cost and value premium. DOE's liftoff report says that you're going to have to spend 5 to 10 billion in capital kind of investment through 2030 to get that full kind of value here in the U.S., but it could yield like $1 billion a year in kind of basically cost benefits for the industry if they do it.
So, Jeff, I was curious. I mean, no one wants their building to fall down or be kind of structurally weakened to reduce 20% of the carbon emissions. But how do you convince the building industry to really pick up these new lower carbon options? And do you need to see a building standing around for years and years before people start to trust the newer materials?
It's a combination of real world experience and the imprimatur of these standards entities that really does it, is what folks I talked to told me. You're absolutely right that you don't just go changing your cement recipe willy-nilly. And there's more than just strength. There's durability. There's set time, how long it takes between when you pour it and when it hardens to the point where you can start building the thing you wanted to build on top of it. I mean, one of the points that Rebecca Dell made is that cement costs are about maybe 2, 3, 4% of an overall building cost. The cost of labor and the time it takes to build a building are a lot higher than that. You could have a much lower carbon cement, but if it takes 3 to 5 times as long to set, which allows you to move on to the next step, it might be a no-go for a construction company.
Also, for the series, we kind of looked at, Jeff's been talking a lot about the solutions that are increasingly available today. And there's also a lot of sort of next generation approaches as well. Companies like Prometheus Materials looking at algae, of course, the unicorn of the clean energy world. Other companies like Forterra are trying to mimic these kind of natural biological processes that coral reefs, oysters use to create their own shells. So they're trying to do that in a lab, essentially, to make the calcium carbonate or the calcium-rich materials that can then become or used in cement.
I talked about the half that was relatively short-term and lower cost to do. The other half of cement emissions is going to be a much tougher lift. DOE's liftoff report separated those into 2 broad categories. One is carbon capture and utilization and sequestration, basically capturing and preventing the carbon that's emitted from the traditional cement making process from getting into the atmosphere. And that's a whole realm of endeavor that we are going to be talking about for all kinds of emitting industries and processes, and it comes with a bunch of well-known challenges. The other option is what Maria was talking about, all these alternative production methods and alternative binder chemistries, basically different ways to make the cement we make today and different cements to make using a variety of different processes. Those are going to be tough for all the reasons we mentioned. People are leery of new cement types, chemistries, recipes, and they're leery of making big investments in an entirely new process that hasn't been tested against the very tough economics of cement production today. But there are some significant pilot projects going on at this point, and it will be very interesting to see how the big cement majors pick up on this in the next couple years.
Yeah, I think you summarized the barriers well. High capital costs, long lifetime of equipment, tight margins, an industry like in the power sector that's slow to change. But when things happen, they can happen fairly fast. So I'm curious, as you've all outlined these sectors, you've painted some of the solution sets. Is there anything that jumped out at you in your reporting that was like near term, you felt like this could happen quickly? And are there any solution sets that are much further in the distance and have a much greater problem with adoption?
Well, I came away feeling a bit more bullish on like low carbon, clean hydrogen's ability to compete in the near term. Because I came at it with this kind of general understanding that you see mentioned a lot that current fossil-based, methane-based hydrogen production is super cheap. Rule of thumb, people say, in the vicinity of $1 per kilogram, and that doing it cleanly is going to cost many times more than that, like 5 more times or something. And that the clean producers are really scrambling up a steep hill. But yeah, what I found from talking to people who are actually trying to make green hydrogen to make money off of it is it's not such a scary economic challenge. For one thing, the credits in the Inflation Reduction Act go up to $3 a kilogram. We're still waiting on the highly contentious rules to say who exactly qualifies for the highest levels of cleanliness. But, so that brings you pretty close to the fossil. And then, like I mentioned, the liquid hydrogen market isn't even really a market today. It's kind of like a handful of legacy producers it's tough to be a customer buying it because there's just not a lot of options. So if you have a bunch of people coming in and starting to make new hydrogen to sell to trucking or forklifts like Plug Power does, that's great. There's demand for that already. You have people like Amazon and these big industrial people like already exploring hydrogen powered vehicles for their operations with a lot of buying power. And then at the end of the day, most of the fossil-based hydrogen isn't really getting sold out to the market anyways. It's kind of being created in these petrochemical hubs and then put right back into refining or chemicals processes. So, it's in some ways a kind of mythical opponent because the places where the super cheap hydrogen is being made aren't necessarily a place you could go and buy it for one of these industrial processes. And if you're trying to clean up your steel so you can sell green steel, like you can't buy the super cheap, dirty stuff anyways. So I came away thinking like there's actually more near-term traction based on price for green hydrogen. And then the people trying to make a living on it say they're eventually going to be the cheapest fuel ever, and they're going to be cheaper than diesel and cheaper than all these other options. I can't speak to that yet, but there's potential that it'll kind of run away faster than we expect.
Maria, across the different sectors that you're covering, what jumps out at you as a solution with the nearest term commercial potential, and what is a solution that feels pretty distant and difficult?
Well, it feels kind of funny to call hydrogen-based steelmaking nearest term, but I think I was really interested to learn in my reporting that from a technology standpoint, the pieces are there. There's the Hybrid project in Sweden is already making steel using 100% green hydrogen. Other projects are in the works. There's about 40, a few dozen in the works. So that was interesting to me to learn that it's not necessarily a technology hurdle, although there are some, things to be ironed out there. Obviously, the main challenge then is, as Julian was mentioning, making enough of the green hydrogen, getting it to where people need it, and then kind of creating the market to justify making these expensive investments and paying more for the green steel. Farther out on the horizon, we talked earlier about my story on electrifying ethylene steam crackers. And while there are a handful of interesting initiatives in the works, they're very early stage. And there are so many technical challenges beyond just how do you produce huge amounts of heat with electricity that still need to be ironed out. And it's kind of still unclear to me what will encourage companies to actually pursue these projects. Obviously, chemical companies, like every company, is under pressure to achieve net zero emissions, but it's not kind of clear if this path will actually pan out for decarbonizing ethylene production, at least.
Jeff, what about you?
The alternative kind of supplementary cementitious materials, it just seems like such a huge opportunity that is largely kind of hinging on inertia to be relieved in order for it to be really picked up in a big way. And so there are a lot of ways to drive down the emissions intensity of cement. And there's kind of closed loop options as well. I think Maria covered a company that is re-injecting captured carbon into concrete, which is, of course, cement plus a bunch of rocks and aggregates and other stuff. And that can actually harden the concrete and improve its structural integrity and capture carbon for a long time. There are some really interesting options for kind of full circle carbon reduction and sequestration involved in that. I would say that the harder sells are the kind of are the brand new processes that we're talking about. Some of the brand new processes for making cement, some of the brand new processes for electrowinning iron. They offer a lot of promise, and there are good kind of economic reasons to pursue them as well. But once again, it's that question of getting these enormous global industries to really invest in retooling their capital plant to go after this. That's going to be tough.
And I think a key part of that is just how massive a scale these players operate at. So that was something I noticed visiting Houston earlier this year, is these are just massive, massive complexes. And so if you have a cool new technology and you've piloted it, at a tiny kind of lab bench scale, there's such a long way to go before it's even just physically big enough to be interesting to these kind of big chemical or industrial facilities. At that point, it's also such a huge capital commitment that there has to be really clear benefits for them to just bother to overhaul such a big endeavor.
I'm just curious if you can characterize the kinds of solutions providers that are operating in these different spaces. And I mean, are they mostly just like teams of engineers who've raised, $50, $100 million from Bill Gates and are working on some fancy technology that they hope to drop in? Is there a lot of sales and development happening, or is it mostly just technological innovation? Does anyone want to characterize some of the commercial landscape a little bit more in terms of companies operating?
I could take a crack for cement real quick, cement and concrete. First of all, about half the world's global cement production takes place in China, and there are some very large companies there. There are a couple of really large kind of global cement producers, Holcim, Cemex, Heidelberg Materials, and there are a wide array of kind of smaller scale players in the cement production industry. And then when you get to concrete, the whole kind of chain from cement to actually building stuff with it is really quite diverse and in some markets quite fragmented. I'm sure you all have driven by the ready-mix concrete sites, along the highway. You got to build those pretty close to where your construction markets are. And so there are a lot of them. Some of them may be owned by the same companies that make cement. Some of them may be essentially mom and pop operations. And so there's a pretty fragmented industry. And then, of course, you've got the thousands upon thousands of kind of contractors and buyers of this stuff. But there's some important distinctions to be made there. Roughly half the cement that's used in the United States, for example, is contracted by governments to build essentially roads and public works. And so there's a real interesting kind of point at which you can focus policy interventions to get governments to set essentially clean building standards or clean building material standards, and not just sticks, forbidding people from selling you stuff that has a higher carbon emissions impact than you want, but really carrots as well, giving people incentives to produce the lower carbon stuff. Rebecca Dell at ClimateWorks pointed out the real value of putting pressure on the demand side, because you can make this stuff anywhere in the world within certain limits of cost of transport and energy. And if you want to avoid regulations, you can probably move to different places and keep making dirty stuff. If you can get the demand side, the buyers, to really offer compelling premiums for lower carbon stuff, combined, of course, with a rigorous, process by which one affirms that these low carbon products are in fact coming with a lower embodied carbon footprint, that can be a real way to drive the kind of investments we're talking about. And she's written posts and papers about why this is a really compelling proposition for cleaning up industry. There are, 85, 90 million households in the U.S. Replacing every gas heater in every household is a pretty big pull. If you can get at a couple hundred major industrial producers and get them to change, that's a big hit right there. And it's a cohesive, coherent approach to driving down a lot of big emissions really, really centrally.
So the supply ecosystem for hydrogen, there's a few different camps there. For the electrolyzers, there's a bunch of these legacy equipment manufacturers like Siemens or Cummins, and they've been around for ages, and they make electrolyzers among the many other things they make. Then there's a crop of new startups that are trying to create new, better electrolyzers. One's called Electric Hydrogen that's raised a bunch of money, but there's a few others like that. And then some of the people who are out actually building hydrogen production have gone vertically integrated. So Plug Power claim to fame was selling all the hydrogen-powered forklifts for Amazon in 2017. But now they have started building their own green hydrogen production to supply lower-cost hydrogen to their customers. And they also acquired an electrolyzer company. So they're able to manufacture their own electrolyzers, sell it to other people if they want, or just like put them into their own projects. So I think that's kind of the spread. You got the legacy ones, you got the new startups trying to build a better tech, and then the integrated developer manufacturer model.
Yeah, so Maria, over to you. Why don't we talk about steel, since we've covered the others?
Sure. So I would say in general, the steel industry is characterized by sort of these large legacy players. In the United States, U.S. Steel and Cleveland-Cliffs are actually the only two companies that still operate blast furnace and basic oxygen furnaces. But there are a handful of other companies that operate these electric arc furnaces using scrap metal, Nucor being one of them. And Nucor is actually America's biggest steel supplier. And then you have kind of a whole range of equipment manufacturers. Midrex is a company that makes these direct reduced iron plants. And in terms of sort of the startup space, obviously Boston Metal, Electra are ones that stand out. But my sense is that right now, that a lot of the innovation is happening right now among sort of these established companies with support from government programs. If you're talking about Europe, especially, a lot of those projects are funded through European Union funding or kind of state-sponsored initiatives.
I want to talk about some optimism here to round out the show. We've outlined some pretty interesting solutions, but some very clear barriers to getting those solutions implemented. But in industry, when you have a limited number of players, as you said earlier, Jeff, if you can get a limited number of players to change their process, change their materials, you can have a huge impact across industry. So at some point, we'll see an inflection point. Can you outline a technological trend or a business shift that gave you optimism in your reporting around solutions in the industrial space?
I was sensing a surprising amount of optimism on the hydrogen front. I mean, maybe I'm kind of an optimistic person, but it seems like we're about to cross this line from there really being no industrial scale clean hydrogen production in the U.S. to there being a bunch in the next 2-3 years even. I mean, yeah, a few projects could be done by the end of the year, but then there's a bunch more breaking ground next year. And I talked to some folks like High Store is planning to spin up a whole new clean industrial kind of complex in Mississippi for 2026, where they say they have industrial customers who want the green hydrogen by then. So they need to start building, and they're going to store it in caves underground and stuff. And so, yeah, it's like shovels going into the ground in a way that was never true before. And I think that's, just a fundamentally new chapter for this industry.
On the cement side, there's so much opportunity, as I mentioned, for getting some really significant gains in reducing carbon intensity of cement with these relatively kind of low cost or even kind of cost advantaged options having to do with, not just, replacing a portion of that cement with other stuff that can kind of improve the structural integrity of it, but also in fundamental energy efficiency. I talked to Holcim that's actually powering its electrical processes with renewable energy at some places. So there are some real short-term gains that are available right now, but also some of these kind of next generation cement chemistries and processes are getting ready to start piloting production right now. Forterra's making its coral-inspired product right now at a plant in Redding, California, and is going to start being ready to bring it out to market for some early-stage opportunities in non-structural concrete next year. The process of building up from building a pilot plant to getting your new material or new process certified by the relevant bodies to getting it into those early projects is going to be happening, and we're going to be able to watch it unfold.
I'd say one thing that gives me optimism is just the amount of public and community engagement around green steel in terms of advocates and organizations starting to put pressure on automakers, for example, to procure more green steel, and sort of kind of bringing this issue out of relative obscurity and kind of making it more central in these conversations about the clean energy transition. So I think that's been really interesting to see how much engagement and interest there is beyond sort of the industrial energy expert side, but actually, making this a very real thing.
And I think if we back up like a year, say 10 years, the conversation then was, okay, the solar, wind, electric vehicles, they seem promising. And then, industrial, who knows? Who even knows? So I do think to come to this point where, steel companies actually have begun building green steel, even at small scale, and cement makers have all these different options on the menu. That's very different from where we were, I think, a decade ago, maybe even 5 years ago, in the kind of big picture sense that solutions are out there.
Well, with that, great series, guys. This is Tough Stuff Week over at Canary Media, so go check out their stories over there. They'll be rolling out these pieces throughout the week, and we'll reference many of them in the show notes. So Maria Galluci, Jeff St. John, Julian Spector, thanks so much.
Thanks, Stephen.
Bye.
The Carbon Copy is a co-production of Latitude Media and Canary Media. This episode was produced by me with help from Delvin Abawaje. Sean Marquand is our engineer, and our theme was produced by Sean Marquand. Latitude Media is supported by Prelude Ventures, a venture capital firm that partners with entrepreneurs across a range of sectors, including energy, food, agriculture, transportation, logistics, advanced materials, manufacturing, and advanced computing. And hook us up if you like these conversations with a rating and review on Apple or Spotify. And you can always find us all on social media. We're still out there posting links, talking about this stuff. So let us know what you think, and send a link to your friend or colleague if they would like this show. And we're so grateful to have you here. I'm Stephen Lacey. This is The Carbon Copy.